Hi everyone, this is Luisa and I'm here with James, and today we're going to present to you the effects of physical pan characteristics and oven type on cookie taste and tenderness. So for our intro, the type of baking surface actually plays a significant role in the final cookie outcome. It impacts the doneness, the flavor, the texture, and the color of the cookies. Texture and flavor is greatly affected by the type of surface that the cookies are being baked on. Dark pans tend to enhance the flavor due to more browning, while light and glass pans may result in softer and lighter cookies. Silicone pans can yield a unique texture, and air pans can promote even baking. Glass pans are not the best surface to bake cookies, hence the lack of glass cookie sheets.
So the procedure that was used to run this experiment um, was was a basic cookie recipe that was just referred to as the basic recipe. And that recipe included an ingredients list that we see on the left here, and then there was a set of cooking instructions that we see on the right. This basic recipe was used for all of the cookies that were cooked in this experiment. So then the there were some pictures taken of how this experiment was actually carried out. So we can see on the left side how the dough was spaced on the different cookie sheets. It was 4 or 5 cookies of each type within different various combinations. And we can see on the left side how they were laid out, different pans spaced out accordingly. On the right side of this slideshow, you can see how they were placed in the oven. And this staggered orientation allows for more of the optimal cooking when we're dealing with specifically convection ovens, because it allows the air to circulate in a way without having the pans to get in the way of the air circulation. So that recipe that I showed was used to cook 4 to 5 cookies in each of these different cooking conditions, and the conditions consisted of a different pan and or oven type combination. So within the conventional oven, we had all 5 of those different cookie sheets used, and then in a convection oven, we had those same 5 used. So it gave a total of 10 different cooking combinations. 5 different cookie sheets in conventional, and then those same 5, but in convection oven. So 10 different combinations. So the results of this experiment, the first results that were recorded was general appearance, and we can see what that appearance is based on just the way that they're oriented. On the bottom group are the conventional oven cookies, and then on the top with the yellow labels, those are the convection cookies. And then going from left to right, we had the dark pan, the light pan, the air pan, the silicone pan, and then the glass pan. So we can see the variation in color. And then the next set of data was tenderness, or like how soft or under, over, or cooked that they were. So the penetrometer was a tool that was used to measure how tender the cookies were, how soft they were. So on the left table is the penetrometer depth test. And then within that table, there is the column for the conventional, and then the column for the convection. And then each of the pans are all the way on the left. You can see what the measurements were for all of the pans within the different oven types. And what stands out is the glass pan had the most depth, allowing the tool to reach down the farthest, indicating that it was the softest of all the textures. And then the dark pan was the least. So that was those were the hardest cookies. And if we were to go back, you could see that the dark pan cookies are the most cooked ones. And then the glass ones, all the way on the right, they're the least cooked ones. And you can even see that one at the very bottom, it doesn't even look like it's cooked all the way. So that was definitely the softest because it was not cooked all the way through. And then if we look at the right table, number of chews was another indicator of how soft or tender the cookies were. And again, the glass pan was the highest in the conventional oven. The convection was actually the lowest, but if we were to look at all of the numbers, that actually just stands out as an outlier. When we look at the graphs here, we can see how significant the trends are and how the numbers actually really fall in line with each other quite nicely, except for that one glass pan outlier and the number of chews. You can see on the bottom right how it stands out as an outlier, but the rest of the data is all very consistent. We can see that the glass pan clearly are the softest and most tender. When you say most tender, that usually sounds pretty good if you're talking about meat, but when you're talking about cookies, you don't really want them to be super tender or overly chewy. That usually means that they're undercooked. But then the dark pan, we can see, is the least soft of all of the cookies.
Okay, so for our discussion, our critical question was, how does the baking pan surface affect energy transfer and thus the final product when baking the cookies? So for our results, actually starting with dark pans, they tend to absorb more heat, which actually leads to quicker browning at the bottom of the cookies, as we saw in the results. This enhances caramelization and this positively affects flavor. However, it also means that the cookies can overbake, so they need to be monitored very closely. For the light pans, they tend to reflect heat, so this results in a more even baking. This typically takes longer for the cookies to brown, so they tend to have a softer texture and milder caramelization, which also affects the flavor. But they also tend to burn less. And then we have the air circulation pans, which actually promotes even heat distribution. And this leads to a more uniform texture since they actually help prevent all the hot spots. And in the results, these cookies, the air circulation ones, were the ones that weren't as brown in the bottom, and they were cooked more evenly.
So then the last two pans, we have the silicone pan. And these are nonstick and they are softer in structure. And this can create thicker edges and softer centers. But since silicone isn't a good heat conductor, it can result in longer baking times and a puffier texture. And then the last pan was the glass pan. And they have low heat conductivity and they take longer to heat up, but they do retain heat well. This can lead to even cooking, which isn't a good thing, which is a good thing. But in this experiment, the cookies ended up being undercooked due to the fact that they needed a longer amount of time to bake, and they did not get that time, hence being undercooked. So this study, a lot of the cooking and the recipe variables were controlled really well, but the sample size was quite small. And within that sample size, the demographics, the anthropometric measures, and the levels of experience of the subjects in that sample varied quite largely. Even though, despite there was significant difference in age and size and experience working with food, the trends that were seen between number of chews, perception of texture, perception of flavor, they were actually quite similar, and they did follow a very noticeable trend, which we were able to see by the data.
And to conclude this presentation, the type of baking surface that is used actually affects the baking time, the texture, and the flavor. As we saw, dark pans tend to enhance the flavor through increased browning and more caramelization, while light pans and glass pans tend to yield softer cookies. Silicone does provide a unique texture, and air circulation pans tend to promote even baking. Regardless of the type of pan that you're using, the most important things is to actually monitor your cookies closely so they do not overbake, or in the case of the glass pans, they are not underbaked. Thank you.
Thank you.